Welcome to mathematics. Now we are in the last session of tangents and normals. Now the last two sessions we have been doing the equation of tangent and equation of normal by finding the slope of the tangent and hence the slope of normal with the help of derivative. And most importantly, the idea which we are using is slope of tangent to a curve is the derivative of the curve dy by dx measured at the point P. Right? This was the idea which helped us to write the equation of tangent and also the equation of normal. Now with the help of tangent, slope, we also have found in the last session the angle between two intersecting curves. Right? Which gave us idea of orthogonality in curves and also the concept of touching of two curves. Now in this session, which is also quite interesting, we'll be doing another application of finding the derivative at a given point which results in the slope of its tangent. Now here what we'll be doing is we'll be finding the lengths of four different quantities. First we'll try to find the length of tangent, then we'll find the length of something called subtangent, then we'll find the length of normal, and we'll also find the length of subnormal. Yeah, you may be wondering, these tangent and normal, they both are infinite lines. They are not segments so that we find the length of this tangent and length of this normal, because they are actually a line which touches the curve at a point. So this is an infinite line. It's not a segment. Similarly, a line which is perpendicular to the tangent at the point of tangency is a normal. So that is also an infinite line. Right? So this is not a segment, then how do we find the length? Now then again there is a problem. These two terms might be something new to you. What is subtangent and what is subnormal? So before we proceed to find the lengths, let's first define what is the length of a tangent, what is length of normal, and similarly what is this exactly subtangent and what is this subnormal. Now let's proceed to define them first, then we will find the lengths of them. Now for the curve y equal to f of x, suppose say at a point P we are drawing a tangent. Now unless the tangent is parallel to x-axis, every other tangent will touch the x-axis at some point, will be cutting the x-axis at some point. Say the point of intersection of this tangent drawn at P to the curve y equal to f of x with x-axis be a point T. Then by definition of our length of tangent, it is nothing but the length PT segment. Now what is this P? It's the point on the curve where we are drawing the tangent. Now as P changes, that is the point of tangency on the curve changes, even the tangent will change. Now as the tangent changes, even its point of intersection with x-axis changes. So for a curve at different points P on it, you will have a different coordinates of t. The distance between the point of tangency to the intersection of the tangent with x-axis, this segment length pt is called length of the tangent. Now similarly, let's look at what do we mean by length of normal. At the point P, when you draw a normal, that means through the same point P which is perpendicular to the tangent, this normal would be also cutting x-axis at a point say N. Then as P changes, even the tangent changes. When the tangent changes, the corresponding perpendicular line normal changes. When normal changes, even the coordinates of N changes, isn't it? Now this segment Pn is called the length of normal. So the length of normal is that segment between the point of tangency P to the normal's intersection with x-axis, that is N. The length of this segment Pn is called the length of normal, right? So the portion of the normal from the point of normalcy to where it cuts the x-axis, this portion is called length of normal. Now similarly, now let us introduce the next two terms. What are they? Subtangent and subnormal. Now what is this length of subtangent? What is this subtangent? Yeah, first try to understand this. What is subtangent? From this point P, which is the point of tangency, let's drop a perpendicular to x-axis. Then this PQ is the ordinate of the point P, isn't it? So PQ is a perpendicular drawn from the point of tangent C to the line x-axis. Now look at the segment TQ. This TQ is the distance between the point of intersection of tangent and the foot of the perpendicular from P on the line. So in other words, shall I say this TQ is the projection of PT on x-axis, isn't it? The length TQ is the projection of length of tangent on x-axis. Now, what is projection of a line on another line segment? Drop perpendicular from both the ends on the x-axis, the distance between them. That means this length TQ is the length of subtangent. So what is actually subtangent means? Subtangent is nothing but the projection of length of tangent on x-axis. So that's why from P we are dropping a perpendicular on x-axis, that is foot of the perpendicular is Q. From T, when you drop a perpendicular on x-axis, it will be T itself. Then the distance between TQ, which is nothing but geometrically speaking the projection of PT on x-axis, this projection is called subtangent. So subtangent is the length of projection of tangent on x-axis, and from the diagram the distance is, it is the length of the segment TQ. Now I think you can define what is subnormal. Yes, the length of subnormal is nothing but, by definition, N is the point of intersection of normal with x-axis and Q is the foot of the perpendicular drawn from P on x-axis. Then this segment QN is the distance between the two foot of the perpendiculars from N and from P, right? So geometrically, what do you call the distance between the two foot of the perpendiculars of a segment? It is nothing but, right, the projection of length of normal on x-axis, and this length from the diagram is the distance between the 2 points N and Q. So if you look at, subnormal is the projection of normal on x-axis and subtangent is the projection of tangent on x-axis. But as tangent and normal are infinite lines, we will treat only the projection of length of tangent. That means PT's projection on x-axis is QT and PN's projection on x-axis is QN. The projection of tangent length is called subtangent and the projection of normal length is called subnormal. Is the terms clear now? Before we proceed to calculate the length of tangent, length of normal, length of subtangent and length of subnormal, let's first try to understand the definition. Tangent being an infinite line, in order to find the tangent length, we need a finite segment. So what are the 2 points where we find the tangent length? It is from the point of tangent C to the point of intersection of the tangent with x-axis. That is, PT is the length of tangent. Similarly, from the point of normal C to the point where the normal cuts x-axis, that is, PN is the length of normal. Then the projection of length of tangent on x-axis is called subtangent and the length of projection of normal on x-axis is called subnormal. Is the idea clear? Right. Now let's proceed to find each of these lengths. First let us try to find the length of tangent. So when we have a curve y equal to f of x and at a point P, when we draw a tangent to the curve, the tangent cuts x-axis at T, then we are supposed to find the length, that is PT length. Now how do we find the length PT? For this, let's take help from trigonometry. So I need a right angle triangle to be constructed. Then from P, we will drop a perpendicular to the x-axis, that is the ordinate of P. Then what kind of a triangle is PTQ? Clearly, triangle PTQ is a right angle triangle, right? And it's a right angle triangle where angle PTQ is alpha. Then if you observe the diagram, alpha is the inclination of this tangent, right? If alpha is the inclination of tangent, shall we say slope of the tangent is tan alpha? But calculus tells us this value of tan alpha is nothing but the derivative of f, that is dy by dx, measured at the point P, isn't it? Now, without knowing alpha, we know that slope of the tangent, which is tan alpha, is also same as dy by dx at the point P. Right? This will be helping us to find the length of tangent. So let's treat this as equation 1. Now, in this triangle PTQ, which is a right angle triangle, we wanted the length PT, but if you look at the diagram, we know the length PQ. Can you tell me what is length of this PQ? PQ is a perpendicular drawn from Px1 y1 on x-axis. So shall we say PQ is the y coordinate of the point, that is mod of y1, isn't it? The y coordinates modulus would always give us the distance from the point P to the x-axis. So we have observed one more thing, that is the length PQ is mod of y1, the ordinate of the P point. So now let's proceed. In the triangle PTQ, which is a right angle triangle, can you define, we need the hypotenuse of the right angle triangle, wherein we know only one side which is opposite to that of alpha. So which trigonometric ratio would help us to find the length of PT, which is in relation to a hypotenuse and opposite side of alpha? Right, we are talking about sine alpha. Then can you tell me what is sine alpha from the triangle? It is the length PQ by the length PT, wherein PQ length we already know, that is mod of y1 by PT is your required length. Now can you tell me what is PT from this? The length of PT is modulus of y1 times cosecant alpha, but in place of cosecant alpha we know a relation in terms of tan alpha. So can we express cosecant alpha in terms of tan alpha? Yes, this can be written as modulus of y1 times square root of 1 plus tan square alpha by tan square alpha. We know the value of tan alpha, that is nothing but dy by dx at the point P. So what happens when we replace PT length in terms of the derivative? It is modulus of y1 times square root of 1 plus dy by dx at the point P whole square by dy by dx at the point P whole square. Right? So once we know the curve, can we calculate dy by dx? Yes. We are given the point P on the curve, then can we calculate dy by dx at the point P? Right? So everything inside the square root is known to us. And then once the point P is given, y1 is known to us. So are we able to calculate the length of tangent PT? It is modulus of y1 times the y coordinate times square root of 1 plus the derivative at the point P whole square by derivative of the at the point P whole square. Then we are able to calculate the length of tangent in terms of the ordinate and the derivative, right? Because you are using derivative to find this length. That's why we treat this as application of differentiation. The derivative would help us to find the length of tangent at a given point. Right? Proceed. Let's now calculate the length of subtangent. What was the subtangent? Subtangent is the projection of length of tangent on x-axis, right? So let's first look at this from the diagrammatical. At the point P, when you draw a tangent which cuts x-axis at a point T, then I need PT's projection on x-axis. So then from T, the foot of the perpendicular is T itself. Then in order to find the projection, we have to find the perpendicular from P on x-axis. Now when we drop a perpendicular from P on x-axis, again from the same idea, this is the ordinate of the point. So PQ length in this is modulus of y1. Now from the diagram, what is your length of subtangent? The length of subtangent is the projection of PT on x-axis. Therefore, we wanted to find the length TQ now, right? We will be finding the length TQ. Now again, for the evaluation of TQ, let's consider the triangle PTQ, which is a right angled triangle. Now in a right angled triangle, angle PTQ is alpha, which is the inclination of tangent. Now if alpha is the inclination of tangent, then we know that slope of tangent, that is tan alpha, but we also know that the same slope of tangent is also given by dy by dx measured at the point P, where y is the curve. Then the differentiation at the point P will give us the tangent slope, right? Now look at the same triangle PTQ. Now which length is required? We need TQ. And what is our known data? We know PQ length. So what is the trigonometric ratio that relates the opposite side of alpha to the adjacent side of alpha? Right, very good. Let's calculate tan alpha here. Then by definition tan alpha is opposite side PQ by your required subtangent length, that is TQ, wherein we know PQ value. So let us replace the known value by TQ is your length of subtangent which we are supposed to calculate. Now what is your TQ length then? TQ length is modulus of y1 by tan alpha. But what is this tan alpha by this known equation? Yes, it is the derivative of the function dy by dx measured at the point P, right? So are we able to calculate TQ in terms of the ordinate y1 by the derivative of the function at the point P, that is dy by dx at P, right? Once we know the curve and a point on the curve, can we calculate both the values on the right hand side? Once we know a point, we know the ordinate. Once we know the curve, we can differentiate, and at the known point P, we can find the value of the derivative which also represents the slope of the tangent. So are we able to calculate the length of projection of tangent on x-axis, that is subtangent length, right? Subtangent length is modulus of y1 by the derivative of the function at the point P. Now let's calculate the length of normal. How did we define the length of normal? It is the distance from point of normalcy to the point where the normal cuts x-axis, right? So first I need to draw a normal at the point P. Let's draw a normal which is perpendicular to the tangent. So now this normal cutting the x-axis at a point N, then what are we supposed to calculate? We are expected to evaluate the length Pn, right? So what are we up to now? To find the length of Pn segment. Now look at the triangle PTN. Is this a right angle triangle? Yes. Where is the right angle located at? The right angle is located at P, because that is the angle between the tangent and the normal. So this is a right angle triangle having right angle at P, and in the triangle angle PTN is alpha. So if you look at, which is also the inclination of tangent, therefore shall we say slope of tangent is nothing but the value of tan alpha, which is the dy by dx derivative of the function at the known point P. Now looking at the triangle PTN, and you wanted to find the length of Pn length, wherein we have already known the value of Pt, which is the length of tangent. So for alpha, you know the adjacent side and you are trying to find the opposite side. So which trigonometric ratio would help us, right? Again, the ratio tan alpha is given by opposite side, that is your required length Pn, by adjacent side, that is Pt, wherein we know the length of Pn, we know the length of Pt, which is the length of tangent, right? So in this quantity, what is our unknown value? Unknown value is only Pn. So let us separate the length Pn, which is your length of normal. What is Pn value now? It is Pt times tan alpha. Do you remember what is Pt, the length of tangent? Yes, it is modulus of y1 times square root of 1 plus dy by dx at the point P whole square by dy by dx at the point P times, now what is tan alpha here? Tan alpha value is again dy by dx measured at the point P, right? Now this dy by dx will cancel each other, leaving us with modulus of y1, that is the ordinate of the point P, times the square root of 1 plus dy by dx at the point P whole square, right? Are we able to calculate Pn length? This Pn is the length of the segment joining point of normal C to the point where the normal cuts x-axis, which is nothing but the length of normal. Now, what is the last part left? We need to find the subnormal, that is projection of Pn on x-axis. For that, let's look at this. At that point P on the curve, we need to draw a normal. So first we have drawn a tangent. A line which is perpendicular to the tangent, that is normal, is drawn, right? Then Pn is your length of normal. But when we need subnormal length, It is nothing but the projection of P on x-axis. Then we have drawn a perpendicular from P to that of x-axis. Right? Now, from the diagram, what is your subnormal length now? Qn is your subnormal length, isn't it? Qn, which is the projection of subnormal on the x-axis. So we are supposed to find the length of this segment Qn, wherein what we know is the length PQ is, yes, the y coordinate of the point, because it is the ordinate of the point P, right? Now let's consider this triangle. Now here we might be need to do some geometrical interpretation. So careful while doing this. What kind of a triangle is PQN? Because you have dropped a perpendicular from P to x-axis. Q is the foot of the perpendicular. Therefore, there is an angle 90 degrees in this triangle. So what kind of a triangle is PQN? PQN is a right angle triangle. Now, PQN is a right angle triangle, and can you tell me what would be the angle at N? Yes, angle PNQ would be the complement angle of angle PTN, right? This angle PNQ would be the complement of this angle, because this is also an angle in a right angle triangle PTN only. So this is nothing but pi by 2 minus alpha, wherein what is this alpha? Where your alpha is the angle PTN, which is the inclination of tangent. If alpha is the inclination of tangent, then we know that slope of tangent is tan alpha by definition, and with the help of calculus this is dy by dx at the point P, right? We'll be using this result in the value length for Qn calculation. Now let's come back to our triangle PQN. Now we have measured this angle, and this angle is 90 minus alpha. For this angle 90 minus alpha, Qn is your requirement, which is adjacent side of 90 minus alpha, wherein you know the height PQ. So can you tell me for this angle 90 minus alpha, which trigonometric ratio would relate the opposite side PQ, which is known, to that of the Qn, that is the adjacent side, which is your requirement? Correct. Tan of the angle at N, that is 90 minus alpha, is the opposite side PQ length by the adjacent side, that is Qn length, right? Now what is tan of 90 minus alpha? We all know this is cot alpha is, what is PQ length? The opposite side, that is the ordinate of the point mod y1 by Qn, which is your length of subnormal required, isn't it? So can you tell me what would be the Qn length? Qn length would be mod y1 times tan alpha, but we know that the value of tan alpha is nothing but the derivative at the point P. So can we write the length of subnormal Qn is mod of y1 times dy by dx at the point P? Are we able to calculate the length of normal or subnormal also? Yes, this is the projection of normal on x-axis, which is of length mod of y1, the ordinate, times dy by dx, that is derivative of the point of the curve at the point P, right? Now with the help of all these four derivations, we have done the length of tangent, the segment between the point of tangent C2, point where the tangent cuts x-axis. Then we have measured the length of normal, that is the distance from a point of normal C to the point where the normal cuts x-axis. And similarly, once the tangent and normal are fixed as a segment, then we measure two more lengths, which are projections of this tangent and normal on x-axis, and they are called subtangent and subnormal, right? Let's proceed to do some more interesting observations by using this tangents and normal equations.